Hello and welcome back to this channel. This is Professor Rajesh Barapte, a book author of 25 plus engineering books. Dear students, today's topic is electrostatics. Actually, it is unit number 2 from the subject Basic Electrical Engineering for the first year engineering students, which is common to all branches. Dear students, if you haven't yet observed earlier videos of unit number 1, do watch those videos. I will provide the link in the description box. In the today's session, we'll be discussing the basic concepts related to electrostatics. We'll discuss electrostatic field, then electric flux density, electric field strength, which is also known as electric field intensity, and the permittivity, in which we'll be studying absolute permittivity and relative permittivity. So let us start with the first part, that is electrostatic field. First part is electrostatic field. Now, what is the meaning of this word electrostatic? It is something related to electrical, and static means the things are not changing, they are fixed. So electrostatic means certain electric charges are constant and that they are not changing. Field, what is the meaning of field? Let us understand one concept. If you will stand very near to some hot body, you are not touching to the hot body, still you can sense the heat waves even if you are not touching to that object. This is because in case of a hot body, heat waves are in a surrounding to that hot body. So this is called as a field. Basically, it is the region where certain forces are present. So electrostatic field means certain fixed electric charges are there, they are not changing, and the charges are static, they are not moving. Field is the region where these forces are present. For example, consider a positive charge. Similarly, consider a negative charge. We know the well-known phenomena. If there are two charges, then if the charges are having same polarity, there will be force of repulsion. If the charges are having opposite polarity, there will be force of attraction. Now, let us first discuss the definition. Electrostatic field is an electric field which is produced by static electric charges. In case of a positive charge, the force lines, these red colored lines, are known as force lines. These force lines comes out, whereas in case of negative charge, these force lines are moving inside the charge. As we discussed, if the polarity is same, there will be force of repulsion, and if the polarity is opposite, there will be force of attraction. So basically, if there are two charges, then force lines can move from one charge to another charge. This is the concept of electrostatic field. The next part is concept of electric flux. For this, we will consider the Faraday's experiment of concentric spheres. Initially, there is only one sphere, say inner sphere. Let us say radius of this inner sphere is A. Outer sphere is not existing initially. There is only inner sphere, and on the outer surface of inner sphere, that means if I will draw inner sphere separately like this, its radius is A, and everywhere on the surface of inner sphere, charge plus Q is deposited. Then this inner sphere is enclosed in some another outer sphere. Let us say the radius of outer sphere is B. There is no electrical connection between the two spheres. Charge is present only on inner sphere, and this is inserted into the outer bigger sphere. There is no connection between these two spheres. Technically, it is said that these two spheres are electrically isolated. So, if I will keep the structure like this, I am drawing outer sphere like this. Initially, there are no charges on the outer sphere. If we keep the structure as it is, after some time, it has been observed that the same amount of charge, that is Q, gets developed on the outer sphere, but it is having the negative sign. Now, the question arises, why this is positive and another one is negative? Very simple. As a convention, inner sphere is a donor which donates charge, and outer sphere is an acceptor. So for inner sphere, sign is plus, for outer sphere it is minus. The important concept is that the charge gets transferred from inner sphere to outer sphere even if the spheres were well separated, there is no electrical connection. This has happened because What we discussed earlier, if this is charge Q, the force lines, which are also called as energy lines, comes out from this charge. So everywhere the charge Q is deposited as shown in this diagram. So all energy lines comes out from the inner sphere. They travel certain distance, but these lines are enclosed by the outer sphere. They cannot escape from the outer sphere. So these energy lines gets deposited on the outer sphere. These energy lines are responsible for transferring the charge from inner sphere to outer sphere. So such energy lines are called as flux lines. So these are called as flux lines. Notation is psi. Mathematically, we can write this as psi is equals to Q. Ideally, if there are no losses in the system, so whatever charge is there on the inner sphere initially, same charge gets transferred with the help of these flux lines or energy lines. So psi is equals to Q. For your information, this statement is also called as Gauss law. Alright, so this is the concept behind the flux lines. Now, come back to this diagram. I have drawn two charges, plus and minus. What we discussed, the charge always or energy lines always starts coming out from plus charge, that is plus Q, and they move towards negative charge, that is minus Q. So I have drawn these lines, which we call it as a flux lines, from plus Q to minus Q. These are called as the flux lines. So direction is from plus Q to minus Q. Now from the exam point of view, if you want to write the properties of flux lines, you don't have to mug up the things. The maximum properties can be written by referring this diagram. How to do it? Observe this flux lines. I have told you simple concept. Flux line starts from plus Q and ends on minus Q. So first property is flux line starts from first Q and ends on minus Q. Second, flux lines never cross each other. They are not getting mixed with each other as shown in this diagram. Total flux lines, that is psi, is equals to Q. That's what we discussed just now. Then flux lines does not depend on medium. So they are independent of medium. What is medium? Medium is like free space or any other dielectric medium. Now, if only positive charge is there, suppose there is no negative charge, what is shown in the diagram? Flux line starts from plus Q and ends on minus Q. But if there is no negative charge, then flux lines will radially comes out. What is the meaning of this word radially? Look at this diagram. Flux lines transfers from inner sphere to outer sphere in the direction of radius of sphere. So this is called as a radial direction. This is called as a radial direction. So flux lines does not depend on medium. Then if only positive charge is present, then flux lines terminate at infinity. Flux lines comes out radially in radial direction and they will terminate, they will end ideally at infinity. Then last is flux lines are always radially outward. Just now we discussed this concept. Flux lines are radially outward. Related to this, there is one important term that is known as flux density. Like any other density, we can easily memorize this definition. It is the flux density. So how to define it? It is defined as flux density is equals to total flux upon surface area. So flux density is total flux upon surface area. The notation for flux density is D, which is equals to total flux. Total flux is denoted by notation psi and surface area denoted by S. Now, how to generate the units? In earlier videos also I have told you, you don't have to mug up the units. From the definition itself, if you simply remember this formula, you can well write the definition. How do I write it? Flux density is defined as total flux per surface charge or total flux divided by surface charge. Simple. Now, how to generate the unit? Flux is psi. Psi is equals to Q. That's what we discussed. Q is the charge which is measured in coulombs. So if I want to generate its unit, I can write it like this: coulomb, that is unit of psi, upon surface area. Surface area is measured in meter square. So it is coulomb per meter square. Next part is electric field intensity. It is also known as electric field strength. So intensity or strength. We have just now discussed the concept of electric field. What I said, in case of a hot body, even if you are not touching to the hot body, if you just stand near to the hot body, you can sense the heat waves. That is called as a field. Likewise, if I am considering a point charge plus Q, just now we discussed, any charge contains certain energy and it radiates, gives out energy lines. So these are the energy lines shown by this arrow. But there is certain region in which these energy lines are existing. That region is called as a field. If the field is related to electricity, it is called as electric field. So simple definition, electric field is the region where forces act, or the region where forces are existing. Now, electric field intensity is the intensity, or in simple language, very simple language, measurement of electricity or measurement of field strength present in this particular area is called as electric field intensity. The notation is E. Mathematically, it is defined as force upon charge. So this is the basic definition. Electric field intensity is force upon charge. Force is denoted by F, charge is denoted by Q. Now, if you want to generate the unit, I can use the simple trick. Force is measured in newtons, charge is measured in coulombs, so its unit is Newton per coulomb. Next, very important part, concept of permittivity. As the name indicates, it is certain kind of permission related to the medium. For example, every medium, almost every medium, creates certain opposition for the signal flowing through it. Even in case of a free space, certain opposition is provided by the free space to the signal passing through it. This is related to permittivity. Just now we discussed one notation, that is D. D is electric flux density. And we also discussed one more notation, that is E. E is electric field intensity. The basic formula or relationship between D and E is D is epsilon E, where epsilon is called as permittivity. It is basically the ability of a medium to allow the things to pass through it. It is called as a permittivity. In very, very simplified language, giving permission for the signal to pass through it is permittivity. So from this basic equation, I can write epsilon is equals to D upon E. You just have to memorize this simple formula. So from this you will get epsilon is D upon E. Now, from the exam point of view, you don't have to mug up the definition. If you want to write the definition of epsilon, that is permittivity, how to do it? It is D by E. So you can write it like this. It is the ratio of electric flux density, D is electric flux density, to electric field intensity. Very simple. Just by remembering this formula, you can write the definition of permittivity. Now, one more important term related to permittivity is epsilon can be written as epsilon 0 into epsilon r. Epsilon is permittivity. Epsilon 0 is permittivity of free space. Permittivity of free space. Epsilon r is known as relative permittivity. What is this concept of relative permittivity? Every medium is having certain tendency to oppose the signals passing through it. It is always measured with respect to the tendency of opposition of free space. That is relative permittivity. That means how much permission, in the simplified language, is given by that particular medium with respect to free space is relative permittivity. If you want to generate equation of epsilon r, you can write it like this: epsilon upon epsilon 0. Very simple. I have transferred this epsilon 0 at the LHS side. Now, how to write the definition? What I said, epsilon is the permittivity, or you can say it is the permittivity of any dielectric medium. So basic formula is epsilon 0, permittivity of free space, into epsilon r, relative permittivity. So epsilon r is epsilon upon epsilon 0. How to define it? It is the ratio of permittivity of dielectric to the permittivity of free space. Very simple logic. So dear students, these are some basic concepts. I have explained you the basic definitions and properties of certain things related to this unit. Actually, it is unit number 2 in the subject basic electrical engineering. So that's it for today's video. Thanks for watching this video. Thank you very much.